In this video, I'll explain about bijective function. A function f from a to b is said to be bijective if f is both 1 1 and onto. So I had already shared the videos on 1 1 and onto function. I had shared the link in the description box. If you have not watched those videos, please watch those videos first before watching bijective function video. So if the function is both 1 1 and onto, so in that case we call such function as a bijective function. 1 1 in the sense distinct elements should have distinct images. Onto in the sense every element in the codomain must have at least one pre-image in the domain. So here consider the function f from R to R, reals to reals, which is given by f of x equal to 2x. Every element of a domain is taken to 2 into x. So as per the definition of the function, half goes to 1, then 1 goes to 2, 3 by 2 goes to 3, and 2 goes to 4, 5 by 2 goes to 5. So if you take any real number from the domain, it is a mapping, it is mapped out to some element in the codomain. So the and distinct elements in the domain will have distinct images. So to prove it is 1 1, we have to consider f of x1 equal to f of x2. Images are equal, so we have to arrive at elements are also equal. So you substitute here 2x1 equal to 2x2, which implies 2 cancels x1 equal to x2. For on-to-ness, that is for surjectivity, take one element from the codomain. This y belongs to R in the sense, so this is codomain. Such that f of x equal to y. We have to write y is the image of some x. That some x should belong to the domain that we have to prove. So as per the definition of function y equal to f of x is nothing but 2x. So solve for x. X is the pre-image, y is the image. Now x equal to y by 2. Pre-image is in this form, y by 2, which clearly belongs to the domain because y is taken from the real numbers. Y by 2 is also a real number. So hence this function is both 1 1 and onto, hence it becomes a bijective function. The condition for bijectiveness is that the number of elements in the domain and codomain must be equal. So that is what the requirement. If they are unequal, then we can't define a bijective function, because if you know already that m less than n, m greater than n, that is the codomain having more elements and domain having more element, what happens in some one case it is not 1 1, in another case it becomes not onto. So in such cases we can't define a bijective function. So to define a bijective function, number of elements in the domain and codomain must be equal. So if n of a equal to m and n of b equal to m, in that case total number of bijective functions is given by m factorial, that is mpm, which is nothing but m factorial. So let me consider a few examples. First example is f from r star to r star, where r star is nothing but r minus set containing 0. 0 is eliminated from the set of all real numbers. I had given you function as f of x equal to 1 by x. We have to check is this function bijective. So here consider f is 1 1. We have to prove bijective means both 1 1 and onto. We have to check is it 1 1, is it onto. So first take images, let f of x1 equal to f of x2. We have to arrive at x1 equal to x2. So substitute f of x is 1 by x. So f of x1 is 1 by x1 equal to 1 by x2. Cross multiply x1 equal to x2. Therefore f is 1 1. This is satisfied. Now for f is on, to take one element from the codomain such that f of x is equal to y. This is the procedure all the time. So f of x is 1 by x, which is equal to y. X comes out to be 1 by y. Okay, clearly this belongs to R star. R star is nothing but domain. I have taken one element from the codomain. Now the pre-image looks like 1 by y. Clearly this kind of pre-image is there in the domain. That is because y is taken from R star. Y is a real number. 1 by y is also a real number. Now chance of infinity won't be there because R star contains all non-zero real numbers. So y can never be equal to 0. Hence x equal to undefined, that possibility will not arrive. So it becomes both 1 1 and onto. Hence we will have f is a bijective function. Second example, f from r to r, f of x equal to 3 minus 4x. The function is given in this way, 3 minus 4x. I have to check is it bijective. So let me check is it 1 1 and is it onto. So take let images are equal, I have to arrive at elements are also equal. So 3 minus 4x1 equal to 3 minus 4x2. 3 cancels, minus 4 cancels, we'll get x1 equal to x2 for any real number, x1 and x2. So hence f is 1 1. F is on to take one element from the codomain. Every element of the codomain should have at least one pre-image in the domain. So let y belongs to R such that f of x equal to y. Substitute the value of f of x. 3 minus 4x equal to y. 4x equal to 3 minus y. X equal to 3 minus y divided by 4. This also clearly belongs to the domain. This because codomain and domain are same here, I am specifying this y is taken from the codomain, and this x belongs to the domain. Because y is a real number, 3 minus y is also a real number, divided by 4 is also a real number. So this kind of pre-image which exists in the domain, hence it becomes onto. For every element of the codomain, we have one pre-image of the form 3 minus y by 4, which belongs to the domain. Hence f is bijective. Uh, Third example, f is both 1 1 and onto, hence it is bijective. Third example, f from R to R, f of x equal to 1 plus x square. We have to check is f 1 1 and is f onto. So f of x is equal, f of x1 equal to f of x2. So that is nothing but 1 plus x1 square equal to 1 plus x2 square as per the definition of function. Then 1 cancels, x1 equal to x1 square equal to x2 square. Now whenever squares of two numbers are equal, can we conclude x1 equal to x2? Let me take example, x1 equal to 1, x2 equal to minus 1, f of 1 is 1, f of minus 1 is also 1, but 1 not equal to minus 1. I can't conclude that x1 equal to x2. This is not possible. Therefore f is not 1 1. If f is not 1 1, no need to check for ontoness, because it can't be bijective. For bijectiveness, both 1 1 and onto, you can stop here. Then this is the last formula. If n of a equal to n of b equal to m, the number of bijective functions from a to b is m factorial. So that is the total number of bijective functions. To have bijection from a to b, number of elements in a and b must be equal. A and b must be equivalent sets, then only we can have bijection. So this is all about bijective function. So bijective function, the concept comes from both 1 1 and onto. If the function is both surjective and injective, in that case only the given function is called as bijective function. I hope you understood the concept. Thanks for watching.